Here are some notes about this flowchart, this concept map thing here. And you might want to have a blank copy of this. It's available in the classroom, and you can put stuff on it as you wish. So I'm going to start at the top, and I'm going to bounce around on this thing, and we'll see what happens. So let's start with matter. Matter is anything that has mass and volume. Okay, so volume is something that takes up space. Mass is the amount of matter in an object, how much, the atoms that make it up. So not everything is matter. Something like light doesn't take up any space, so it doesn't have a volume, so light is not matter. Something like a wave doesn't have any mass, so a wave isn't matter. Is air matter? Students sometimes wonder if air is matter. Yes, it is. It takes up space because we use it to fill basketballs, and it has mass because if it didn't, Earth's gravity wouldn't hold it down for us to breathe. So yes, air is matter. So I'm going to go toward the left side here first, and let's talk about pure substances. You can look around, you can find lots of different definitions for pure substances, but the way I think of it is a pure substance is something that has a formula. Okay, so a pure substance, something like sodium, that happens to be an element. Elements are all pure substances. Now if you take sodium and put it with chlorine, you get NaCl, table salt, and this is a compound. So pure substances can be represented with a formula. That's the way I remember it. If you find something better, please let me know. So can you go back and forth between elements and compounds? Sure you can. You can take a compound and you can use some sort of a chemical process and you can split it into elements. What's an example of that? You can run electricity through water and split it into hydrogen and oxygen. So if you take water and add some electricity, I'll draw a little spark here, a little lightning bolt. If you take water and electricity, you can get hydrogen gas and oxygen gas. So you can go from compounds to elements, and you can go back from elements to compounds. And these things that go back and forth, these are called chemical processes because you get some new chemical. That's a topic for discussion later. So those are pure substances, things that have a formula. Now, if something is not a pure substance, it is a mixture. Mixtures can be distinguished or separated from pure substances by physical processes. What's a physical process? A physical process is something where you get nothing new. And I'll put new in quotes because, like, if you boil water, you do get water vapor and you get steam and stuff, but it's still H2O. So I'm going to say nothing new. So a physical process would be something like breaking or sifting or melting or freezing. Those are physical processes. So you can use physical processes to separate mixtures into pure substances. Okay? So a mixture, then, unlike a pure substance, mixtures don't have formulas, and mixtures have they're more easy to separate in my mind. So mixtures are things that are not chemically bonded to each other. So like in a salad, you got a piece of tomato over here and some lettuce over there. That's a mixture, and those particles are not chemically bonded to each other. Chemical bonding is another topic that we'll cover in the future, but for now I hope you get the idea that if the particles aren't hooked to each other chemically, then you have a mixture. Now, homogeneous. Homogeneous mixtures, so there's a couple kinds of mixtures here. Homogeneous mixtures look the same all over. What looks the same all over? Kool-Aid, a glass of water looks the same all over. A brick of lead, something that just appears the same all over is homogeneous. Now this image says inhomogeneous. That's a word that I'm not that familiar with. I mean, I know what it means, but the way that I usually say it is heterogeneous. Heterogeneous, or in the case of this picture, inhomogeneous, means it doesn't look the same all over. So if you can see different parts to it, then it's heterogeneous. In many cases, things that look homogeneous from a distance can look heterogeneous if you get close enough. But these are words that you use when describing things. You know, the way that they appear to you, these two words work great. You know, if something looks different all over, you'd say, oh, that's a heterogeneous mixture. It looks different all over. So there's a lot of information on this little picture.